a simple pendulum? A simple pendulum is essentially a mass hanging from a string that is attached to a pivot point. This mass gets displaced and swings in a periodic motion. The initial angle should have little to no effect on the period because a pendulum swinging through a large angle will have a higher acceleration than a pendulum swinging through a small angle. We will show this by analyzing the period of one mass at 3 different angles: 30 degrees, 45 degrees, and 60 degrees. But what is a period? A period is the time it takes to complete one full oscillation. This graph shows you what we'll be looking for in our own data later on. Here is an example of one of our setups. So on the left is the data points that we collected from the video analysis. From this, we gathered the line of best fit and put this into Desmos to easier compare all of the waves overlaid later on. This graph is shown on the right. Here are the data points for all of our runs. Here's that overlaid graph I was talking about earlier. Of course, it isn't a perfect overlay due to simple mechanical errors, but when we zoom in and look at the period, you can see the similarities. Remember from earlier that the portion of the graph that we're looking at is the portion where this green line is. Recall that the x-axis is time. You can clearly see that each of our runs has a very similar period, meaning that it takes a similar amount of time to complete one full oscillation. Here's the equation for period. You can see that initial angle is not one of the variables that affects t. Again, this is because pendulums that start at a bigger angle have longer to speed up, so they travel faster than pendulums that start at a smaller angle. This leads to a larger acceleration, which leads to similar periods at different initial angles.